In this lesson, we're going to determine if a relation is a function, and we're also going to find the value of each function. Okay, so here is a function that will help you as a visual. So there is one and only one output for each input. Okay, so what I mean by that is here x is your input, so it's going into the box. Okay, something is happening, we're doing the equation, and out comes the output, okay, or what we're going to call the range. Okay, so here's an example of function notation. Okay, so this is really similar to what you've seen before, it just looks a little bit different. Okay, here we have y, which is the output. Okay, so like your answer, what comes out. F is the name of the function, okay, and the x is the input. Okay, so what we're putting into the equation. Okay, so here, if a domain is paired with only one range, then it is a function. Okay, so here my domains are paired with a range. Okay, in the second one, if a domain is paired with more than one range, then it's not a function. Okay, so we can see here of the domain -3, 2, and 2. So in this coordinate, I have 2 is paired with 5, and 2 is also paired with 4. Okay, so this cannot be a function. Once we have an input, we can only have one output from that input. Okay, so just remember that if you have the domain that has 2 separate ranges, it's not a function. Okay, so let's determine whether each of these relations is a function. So if we look at the domains, here our input value, okay, and then we see what the output is. So for 2, output here is 3. For 3, the output is 0. For 5, our output is 2. And for 4, our output is 3. Okay, so none of the input values are repeating. Okay, so yes, this would be considered a function. Okay, it is okay to have different domains that produce the same range. Okay, so take a moment and try this one on your own. Okay, so let me write in these because they're missing. We have 4, 5, 5, 6, and 1. Okay, so if I look at the domain and range for each, so input 4, output 1. Input 5, output 2. Input 5, output 3. Okay, so right away here we can see a problem that I can't have the same input with a different output. Okay, so this is not a function. Okay, the next thing that we can test to see if these are functions is to do a vertical line test. Okay, so if any vertical line passes through more than one point, then the relation is not a function. Okay, so below here are some examples. So the line in red here is my graph. Okay, so I'm going to go ahead and do the vertical line test and see that it only goes through one time, so yes, this is a function. Okay, let's try it for the next one. Yep, my line's only going through one time, so again, this one will be a function. And then if I try the last one, here I see that it's passing through twice. Okay, so this would not be a function. Okay, just take a minute and try to do these on your own and then check back. Okay, so if we look here, the line is the one that's in red. Okay, so if I do my vertical line test through here, it's only passing through one time. Yes, this is a function. This one's a little bit tricky because if I go through, it's okay here, but when I go down, this is all directly on top. So no, this would not be a function. Here I'm passing through twice, which is no. And then the last one here, this would be yes because it's only going through one time. Okay, so the next part is now we're going to try and solve for the functions. So if we see number 1, f of 3 is equal to 7. Okay, So the 3 here is our input. So on the left side here, I'm going to put my 3. I'm going to input it into my equation. This box in here, we can write our equation. So instead of x, I'm putting in 3. So here's my input. This becomes 9 minus 2, which is 7, which is my output. Okay, so I put in 3, and out comes 7. So here I have f of negative 2. So negative 2 is my input. We're putting it in this little machine. Okay, so just think that it's doing something and going to produce an output. So if I plug in negative 2, I have 3 times negative 2 minus 2 is negative 8. Okay, so here my input is negative 2, my output is negative 8. Okay, so here we have h of z is equal to z squared minus 4z plus 9. Okay, so I need to find h of negative 3. So the negative 3 here is my input. So wherever I see a z, because here I have h of z and h of negative 3. So negative 3 I'm going to put where I see z. So negative 3 squared minus 4 times negative 3 plus 9. Okay, so negative 3 squared is 9. Negative 4 times negative 3 is 12 plus 9. Okay, so when I add 9 plus 12 plus 9, I get 30. Okay, so here my input is negative 3 and my output is 30. Okay, so just remember that when we're talking about input, we mean the domain. And when we're talking about output 30, we mean the range. Okay, so pause the video for a moment and try this one on your own. Okay, so here we have g of x is equal to x squared minus 2. So we have g of 4, so our input is 4. We're going to input that into our equation. 4 squared minus 2. Okay, so then we have 16 minus 2, and our output here is 14. So input 4, output 14.